Greetings, my name is Aiman Safwan bin Jeffrey with a metric number of U2004637/1. Today I'm going to present about power bipolar transistor. The power bipolar transistors was invented by three scientists, John Bardeen, Walter Hirschberstein, and William Shockley. These scientists who worked at Bell Laboratories jointly received the Nobel Prize in Physics in 1956 for their invention. Their discovery marked a significant milestone in the development of electronic device as it is a basic building block of any digital component these days. Before the advent of transistors, vacuum tubes were widely used as electronic components for various applications. However, transistors eventually replaced vacuum tube for several reasons. Vacuum tubes were large, bulky devices that required a significant amount of space. Transistors, on the other hand, were much smaller and more compact. Vacuum tubes consumed a substantial amount of power and generated significant heat. In contrast, transistors were more energy efficient and produced less heat. Vacuum tubes were relatively fragile and had a limited lifespan. They were prone to failure and their filaments could burn out over time. Transistors, being solid-state devices, had no moving parts and were more robust and durable. The power transistor (BJT) is a vertically oriented device having a large area of cross-section with alternate P and N-type layers connected. It consists of a three-region structure of N-type and P-type semiconductor materials that is designed either using NPN transistor or PNP transistor. The following construction shows a PNP type where the emitter terminal is connected to a highly doped N-type layer below, which a moderately doped P layer of 10 to the power of 16 cm³ concentration is present, followed by a doped N layer of 10 to the power of 14 cm³ concentration, which is also named as collector drift region. At the bottom, it has an N-plus layer which is a highly doped N-type layer of 10 to the power of 19 cm³ concentration, where the collector is etched away for user interface. The operation of a power bipolar transistor involves the control and amplification of electrical signals. The power bipolar transistor is capable of amplifying electrical signals when a small current or voltage is applied to the base emitter junction. It controls a larger current flowing between the collector and the emitter. In the active mode, a small forward bias voltage is applied between base and emitter. This causes a small base current to flow, and the base emitter junction becomes forward biased. As a result, a larger current flow from the collector to the emitter. The transistor operates as an amplifier in this mode, with the collector current being a multiple of the base current. The power bipolar transistor can also function as a switch, controlling the flow of current between collector and emitter. This switching action is achieved by controlling the bias voltage applied to the base emitter junction. When no current flows between the base and emitter, the transistor is in cut-off mode. In this state, the transistor acts as an open switch and there is no current flow from the collector to the emitter. In saturation mode, a sufficiently large forward bias voltage is applied between the base and emitter. This causes a larger base current, resulting in the transistor operating at its maximum current carrying capacity. In saturation, the transistor functions as a closed switch, allowing a significant current to flow from the collector to the emitter. The graph below represents various regions like the cutoff region, active region, hard saturation region, quasi-saturation region. For different values of VBE, there are different current values of base current from 0 to 6. Whenever there is no current flow, it means the transistor is off, but few current flows which are ICEO. For increased value of base current from base current 0, which is the minimum value, and base current 6, which is the maximum value. Once the collector current has reached to maximum, the transistor switches to the saturation region, where it has two saturation region, quasi-saturation region and hard saturation region. A transistor is said to be in a quasi-saturation region if and only the switching speed from on to off or off to on is fast. This type of saturation is observed in the medium frequency application, whereas in a high saturation region, the transistor requires a certain amount of time to switch from on to off or off to on state. This type of saturation is observed in the low frequency applications. Power bipolar transistors have a significant relevance in several consumer electronic applications. It is most used as either electronic switches in digital circuits or as an amplifier. Switches turn on and off, where for transistor, it acts as such by creating a binary on or off effect of a switch, hence not requiring an actuator for it to flip, but instead it requires voltages. Transistor as switches can be seen in memory devices, in memory chips, which are commonly used in electronic devices like laptop to store and retrieve digital information. The control circuitry applies a voltage to the transistor's gate terminals to turn the transistor on, allowing current to flow through the transistor and charge or discharge the capacitor. The amount of charge stored represents the binary data being written. Apart from working as a switch, transistors are extensively used in audio amplifier for various consumer electronic devices such as speaker, headphones, and home theater systems as well. These amplifiers receive weak audio signals in the form of tiny electric current and amplify them to produce a higher current output, meaning that a louder and more powerful sound output. In conclusion, the power bipolar transistor, invented by Bardeen, Brattain, and Shockley, has revolutionized the field of electronics. Its ability to amplify and control electrical signals has made it an essential component in various electronic devices. From the consumer electronics perspective, the power bipolar transistors plays a crucial role in shaping our daily lives and advancing technology as a whole. Thank you.